Were. Okay? It's actually from, okay? It's actually from, the origin is this word. Aqua. It's Greek. Most of the science words originated from Greek or Latin. Okay? So this means water in Greek. Okay? It means aqua, water. So AQ means the substance is what? Dissolved in water. Dissolved in water. Okay? So the next one will be this one, right? Who read it? What does this mean? When you see the sign on the yield, it means what? Heat. Okay? So it's either represented by this delta sign, small triangle, or the word heat. Does that make sense? Means for that reaction to go on, you must heat it. Okay? Burn it a little in fire. Okay? That's what it means. Then the next one will be this one that has PT. PT is the symbol for platinum. Okay? Is the symbol for what? Platinum. Okay? Right one? Please read the meaning of catalyst. Read the meaning of catalyst. Listen, read the meaning of catalyst. Substance. Use up in that reaction. Okay? So when you see this, when you see the symbol of any element on the yield sign, it means it's being used as a catalyst. Okay? And Red One just read the meaning of catalyst for us. A substance that speeds up. Speeds up means makes it faster. Okay? So a substance that makes the rate of the reaction faster, but is not used up in the reaction. So what that means is, if I have PT here, okay? If I have this element here, okay, it's only going to make this reaction faster, but it won't be part of it. That's why you will not find it in your products. Does that make sense? You will not find it in your products because it's not used up. It's only there to make the reaction what? Faster. Okay? So these are the symbols that we need as we learn how to balance equations. Okay? You're not going to learn it all in one day. And that's why I have asked you to have it in your notebook, so that as we go on, you begin to learn the more. Okay? So now let's look at this. Solid sodium combines with chlorine gas to make what? Solid sodium chloride. So this will be the word equation. Okay? So solid sodium, okay, combines plus chlorine gas to make what? Sodium chloride. Okay? So maybe tomorrow we will get the worksheet that we have to write some of these word equations in skeleton equation. Okay?
Can we do that today?
Depending on how we go. Okay? Depending on how we go, we'll do that today.
We may do it right now. Yeah, bad now. Right now we will. I stop sleeping now.
Okay.
Let it homework. That's a taxi. Homework.
Sullivan, read what we have on the board.
Over.
And a chemical reaction has an inner equation. Go closer. The law of what? Conservation of mass. The law of what? Conservation of mass. Thank you. Okay, that's fine. Come back. So the law of conservation of mass. The law of conservation of mass. So what does the law say? That matter is neither created nor destroyed. Okay? So in a chemical reaction, you do not create new elements. Okay? You make something new, quite alright, but you do not create new elements. It's just like the way you are sitting in this class. Okay? I can decide tomorrow to move Huder to this position and move Abdul Nasir to go sit with Rhoda. What have I done? Rearrange. Okay? Rearrange. Okay? And when I rearrange, I will get a new sitting arrangement. But the students will remain the same. Does that make sense? I am not bringing in new students, and I am not taking out any students. So when you have a chemical reaction, you have the same elements on both sides, but the arrangement will be what? Different. So let's look at the equation we have here. We have carbon, we also have it here, okay? We have hydrogen, and we also have it in the products. We have oxygen in the reactants, and we also have it where? In the products, okay? But what we do not have is this. What we do not have is number 3. Alexander, can you read this for us?
This means that you have to have the same number of each type of atom on each side of the
Chemical equation. Exactly. The same number on each side of the chemical equation. But do we have the same numbers here?
Yes.
Okay, let's find out. Do we have the same numbers? Rhoda?
Yeah.
How many C do we have here? 2. And how many do we have here?
2.
Look at this very well. How many?
4.
Who is saying 4?
1.
It's 2.
How many do we have here?
1.
1.
Yeah, 1.
Are they equal? Okay. How many hydrogen do we have here?
4.
And how many do we have here? 2. Okay?
6.
So that's why we will need to do what? Balance equations. We will need to do what? Balance equations. Okay. Hassan?
Yeah.
I told you to start that. You're already done with your do now.
6417.
What? Oh. Okay. So what do I have on the board?
Scale.
What do I have on the board?
Scale.
Okay, and after the scale, what do I have? Balancing equations. Okay? On both sides. Okay? And that's what we're going to do now. Okay? So after you write a chemical equation, you have to balance it to make sure that the same number of atoms of each element are on each side. Okay? So now let's look at our carbon. How many do we have? 2. And how many do we have here? 1. Okay? But in balancing equations, we do not touch the subscripts. We do not do what? Touch the subscripts. We use coefficients, the one we write in front. Okay? So if we have 2 carbon here, and we have 1 carbon here,
2.
we can add 2. Okay? You see why I said pay attention? Okay? We are trying to balance the equations. So in balancing equations, we will now use coefficients. That's what we can change, but we cannot touch the subscripts. Okay? So if we have 2 carbon here, Then we also make this 2. How many hydrogen do we have here?
4.
So how many do we have here?
2. You need 2.
So how do we make this 2? Before,
2.
put 2 here.
You're welcome.
So how many hydrogen do we now have?
4.
Okay? How many oxygen do we have here? 2. Now I want you to please look at this and tell me the number of oxygen atoms. Do not guess. Make sure you look at the 2 products. Tell me. Do not guess, please. Look at the 2 products and tell me how many oxygen we have.
6.
6. Good job. Okay? So we have 6 oxygen atoms here. How did we get 6? 2 times 2 gives us 4. Then 2 times 1 gives us 2. Making it what? 6. But how many do we have here?
2.
So what do you think I should write here in order to make this
3.
6?
3.
4.
Wait. Okay, calm down. Look at it again. I have 2 here. When I added this 2 and multiplied by the subscript of 1, I got 2. So what number should I write here in order to make oxygen? 6. Bearing in mind that the subscript is 2.
No.
Not you, Alexandra. Think.
It's not 3?
No, I said not you.
Oh.
Yes?
The rest.
Okay? 3. Okay? So 3 times 2 will give us what? 6. Okay? So now let's look at the equation again. Let's look at the equation again. How many carbon do we have? 2. How many do we have here? 2. How many hydrogen do we have here?
4.
How many hydrogen here?
4.
How many oxygen?
6.
5.
5. No.
6.
Please don't add. You're multiplying. How many oxygen? 6. And how many oxygen here? 4. How many here?
6.
Making a total of what? 6. So here, okay? So the numbers I have written will be what? And then these 3 numbers will be what? Okay, coefficients. Good job. Okay?
You're welcome.
Obiesie. Okay? These ones will be what? Subscript. Say it. Subscript. Again? Subscript. Okay? Familiar? These ones will be what? Familiar? Subscript. Okay.
Man, you think about something else, like, you know what I'm saying? Think about the growth. Come on. What is this?
You were not here yesterday.
Let me just get it, man.
I'll give you.
I'm gonna see you, hey, no bad words, you know? Don't use it.
Who teach you that? Stop using bad words.
Don't use bad words. No man. 6417. We're gonna be back up. This new stuff for us. Just bring the shower. Catch up. So like,
Right. Go and sit with Rhoda. Go and sit with Rhoda. How many of you were not here yesterday?